Hello, my dear students. How are you all? I am fine. I am Khandakar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. My dear students, during this pandemic situation, welcome you all to our online chemistry class. Today, we discuss about some important topics from chemistry first paper, chapter 3, periodic properties of elements and chemical bonds. My dear students, the physical and chemical properties of elements depends on the electronic structure of their outermost shells. The electrons with similar electronic structures of the outermost shell exhibit similar properties. On the basis of electronic structure, elements have been divided into four blocks. First one, S block elements, P block elements, D block elements, and F block elements. My dear students, at first we discuss about what is S block elements. Here I write what is S block elements. The elements in which the last electron enters into the s orbital of their outermost energy level are called S block elements. Total S block elements in a periodic table is 14, and the electronic configuration of S block elements is ns1 and ns2. My dear students, for example, we can say such as beryllium 4, 1s2, 2s2. The electronic configuration is ns2. My dear students, for sodium we can write here Na 11, 1s2, 2s2, 2p6, 3s1. My dear students, here we can see that the electronic configuration is 3s1 for sodium, and electronic configuration of beryllium, that is 2s2, that means ns2. My dear students, and for another example we can also write here magnesium. This is 12, 1s2, 2s2, 2p6, 3s2. My dear students, here the last electron enters into the s orbital, and that's why this magnesium is S block element, and similarly beryllium, sodium also S block elements. So my dear students, now we can say that in a periodic table, my dear students, in a periodic table, group 1 elements and group 2 elements are known as S block elements, because group 1 elements are group 1 elements here hydrogen, lithium, sodium, potassium, rubidium, and cesium. These elements and their last electron enters into s orbital, and the general electronic configuration ns1, and that's why group 1 elements are known as S block elements. Similarly, group 2 elements here beryllium, magnesium, calcium, strontium, barium, and radium. These elements here their general electronic configuration ns2, because their last electron enters into s orbital, and that's why group 1 and 2 elements are known as S block elements. And similarly helium, my dear students, which is present in group number 18, and its electronic configuration 1s2, that's why helium also S block elements, and this total 14 elements in a periodic table are S block elements. And the ns1 elements except hydrogen, my dear students, the ns1 elements except hydrogen are called alkali metals, because these metals react with water and produce strong alkali and hydrogen, and that's why these elements are known as alkali metals. That means group 1 elements except hydrogen, lithium, sodium, potassium, rubidium, cesium, francium are known as alkali metals. and the NS2 electronic configuration elements except helium are called alkaline earth metals, and they are present in group number 2. My dear students, they are present in group number 2, and they are beryllium, magnesium, calcium, strontium, barium, and radium. My dear students, now what is p block elements? The elements in which the last electron enters into p orbital of their outermost energy level are called p block elements. Total p block elements in a periodic table is 36, and the electronic configuration of their outermost energy level is ns2 np1 to 6. For example, my dear students, we can write here boron 5, 1s2, 2s2, 2p1. Here we can see that the electronic configuration is similar to ns2 np1 to 6, that is 2s2 2p1. For carbon, for example, we can write here carbon 1s2 2s2 2p2. This is also p block element because the last electron enters into p orbital. And if we write the electronic configuration of chlorine 1s2 2s2 2p6 3s2 3p5. My dear students, here the last electron enters into a p orbital, and that's why this is also p block elements. And the p block elements present in a periodic table from group number 13 to group number 18 except helium. My dear students, now d block element, the elements in which the last electron enters to the d orbital which is inner to the outermost shell are called d block element. Total d block element is 41, and the general electronic configuration of d block elements is n-1 d1 to 10 and ns1 to 2. My dear students, for example, we can write scandium 21 1s2 2s2 2p6 3s2 3p6 3d 4s2 and 3d1. My dear students, so which is similar to n-1 d1 and ns2. So this is d block element. For another example, we can write iron 26 1s2 2s2 2p6 3s2 3p6 3d and 4s2 3d6. This is also d block element. D block elements which have partially filled d orbital in its outermost shell in the stable ionic state are called transition element. My dear students, now what is F block elements? The elements in which the last electron enters into the F orbital are called F block elements. Total F block elements are 27. Electronic configuration of F block elements are n-2 F 1 to 14, n-1 d10 and ns2. This is the electronic configuration of F block element. The F block elements consist of two series of elements which are placed in two rows and bottom of the periodic table. These are known as lanthanide series and actinide series. In lanthanide series, lanthanum to lutetium, and actinide series, actinium to lawrencium elements are present. My dear students, now we discuss about general characteristics of S block elements. In case of these elements, all shells except the outermost one are completely filled with electrons. Except hydrogen and helium, Each element of this block is a metal and very reactive. Due to the weak attractive force of the nucleus for the valence electrons, the atoms of these elements can easily form monovalent or bivalent cations by losing one or two electrons. That is, the ionization potential of the elements is very low. Because of high reactivity, these elements do not occur freely in nature. Because of the low value of ionization potential, all these elements are good reducing agents. They are good conductors of heat and electricity. They are soft metals. They have low melting and boiling points and low densities as compared to the adjacent transition elements. Cations of these elements of group 1 and group 2 are diamagnetic and colorless since their orbitals do not contain odd electrons. Except beryllium and magnesium, S block elements shows specific color to the flame test. Salt of these elements except dichromate and chromate are colorless. Compounds of these elements are mainly ionic. Only lithium and beryllium can form covalent compounds in many cases. They form stable oxides with oxygen such as sodium oxide, calcium oxide. Reacts with chlorine to produce chlorides such as sodium chloride, calcium chloride, and give rise to salt like hydrides with hydrogen. The hydroxides of these elements except calcium hydroxide, magnesium hydroxide and beryllium hydroxide are soluble in water at ordinary temperature. My dear students, now we discuss about general characteristics of p block elements. Most of the p block elements are non-metals, some are metals and a few others are metalloids and inert gases. On moving from group 13 to group 17, the valence electrons of the atoms of the elements are found to be more strongly held by the attractive force of the nucleus, resulting a progressive increase in ionization potential. Again, on moving down a group due to gradual decrease in ionization potential, metallic character increases. Hence, metals exist at the bottom of the left side of the p block, whereas non-metals lie at the top of the right of the p block. Metalloids, boron, silicon, germanium, arsenic, antimony stand midway between them. Most of them form covalent compounds, although ionic character increases. Elements of this block are non-conductors of heat and electricity, except metals and graphite. Elements of this block are mostly electronegative in nature. They exhibit variable oxidation state or valence states. Oxidation states may be both positive and negative. On moving from left to right, that means group number 13 to group number 17, across a period, reducing power decreases with the simultaneous increase in oxidizing power. Again, from top to bottom, in the same group, reducing power gradually increases while oxidizing power gradually decreases. They can form both colored and colorless compounds. My dear students, now we discuss about general characteristics of D block elements. All D block elements are metal. Their ionization potentials lies midway between those of S and P block elements. Elements of this block exhibit variable oxidation states and valences because of the presence of partially filled d orbitals in their atoms. Ns electrons and different number of n-1d electrons participate in bonding at the time of reaction with atoms of other elements. They are solids except mercury, hard and have high melting and boiling points. They can form both ionic and covalent compounds. They exhibit paramagnetic character due to the presence of one or more unpaired electrons in their atoms or ions. Exception: scandium 3 plus, titanium 4 plus, zinc 2 plus, copper plus, which do not contain odd electrons, are diamagnetic. Iron and cobalt can be converted into magnets and hence they are ferromagnetic. They frequently form colored ions. They are less electropositive than S block elements. A number of transition metals such as chromium, manganese, iron, cobalt, nickel, copper, etc., and their compounds are used as catalysts. Many transition metals form alloys. My dear students, now we discuss about general characteristics of F block elements. They are all heavy metals. They exhibit variable valency. +3 oxidation state is most common. Few elements are found to occur in +2 and +4 oxidation states. Some members exhibit paramagnetism due to the presence of odd electrons. They form complex compounds, most of which are colored. They have high densities. They generally have high melting and boiling points. Within each series, the properties of the elements are quite similar. It is very difficult to separate them from a mixture. Actinide elements are radioactive. First three members, thorium, protactinium, uranium, occur in nature, while the others are man-made. Now, my dear students, we discuss about determination of group and period of element in a periodic table. My dear students, at first we discuss about determination of period in a periodic table of elements. My dear students, we know that the maximum principal quantum number of an element represent their period in periodic table. So, if we write the electronic configuration of sodium Na 11, 1s2, 2s2, 2p6, 3s1. My dear students, here the maximum principal quantum number is 3. So, here we can see that the period is 3. For chlorine, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. My dear students, here the outermost shell is third shell, so it is also present in period number 3. Period number 3. And if we discuss about for carbon 6, 1s2, 2s2, 2p2. Here the maximum principal quantum number, that means the outermost shell is second shell, so this carbon present in second shell, this is period number 2, my dear students. So now we can learn how can we calculate the period of an element in a periodic table. Now, my dear students, we discuss about how can we determine the group of elements in a periodic table. My dear students, at first, S block element, S block element, my dear students. For S block element, the number of electron present in ns orbital is the represent the group number of that element. For example, my dear students, if we discuss about beryllium 4, 1s2, 2s2. My dear students, here in outermost shell, that means 2s orbital contains 2 electron. So this beryllium present in group number 2, and the maximum principal quantum number, that is 2, or the outermost shell is 2, so it is present in period number 2. For sodium, my dear students, electronic configuration 1s2, 2s2, 2p6, 3s1. Here the outermost shell is 3, so this sodium present in period number 3, and here the s orbital contains 1 electron, so this sodium present in group number 1. Now, my dear students, we discuss about p block element. The group number is number of electron present in ns orbital and np orbital plus 10. My dear students, number of electron present in s and np orbital plus 10. This is the group number of p block element. For example, if we discuss about carbon 6, 1s2, 2s2, 2p2. So, my dear students, here the outermost shell is second shell, so this carbon present in period number 2, and group number in s orbital 2 electron present and p orbital 2 electron present, so group number 2 plus 2 plus 10, that means group number 14. So we can say that carbon present in group number 14 in a periodic table. For another example, my dear students, if we write chlorine, here 17, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. Here the outermost shell is third shell, so chlorine present in period number 3, and group number of chlorine, here s orbital contains 2 electron and p orbital contains 5 electron. So group number 2 plus 5 plus 10 equal to 17. So my dear students, chlorine present in third period and group number 17. Now my dear students, we discuss about the position of d block element in a periodic table. Here the electron present in n-1 d orbital and ns orbital. The electron number of n-1 d and ns orbital represent the group number of d block elements. And my dear students, for example, we can write here scandium 21, 1s2, 2s2, 2p, 6, 3s2, 3p6, 3d, 4s, 1 and 2. Here the outermost shell is fourth shell, so scandium present in period number 4, and here in d orbital n-1 d orbital and ns orbital contains total number of electron 2 plus 1 equal to 3. So group number equal to 3. So we can say that scandium present in group number 3 and period number 4 in periodic table. For another example, my dear students, we can write iron 26, 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s, here 2, here 6, and the outermost shell of iron is fourth shell, so this iron present in fourth period 4, and the total number of electron present in 3d and 4s orbital 6 plus 2. So iron present in group number 8. Oh, my dear students, we discuss about the position of F block elements in periodic table. My dear students, we know that all F block elements present in group number 3. That means all F block elements present in third group. And now we discuss about the period of F block elements. My dear students, F block elements, for example, we discuss about cerium 58 electronic configuration. This is xenon 4f2 and 6s2. So my dear students, the position of cerium, that means its period is highest, that means outermost energy level 6 energy level. So here its period is 6.